page 28, and we'll go through this conjecture problem together. This one won't be as long as the previous one. So we have considered the function x on x plus 1. The graph is shown below. On the graph, draw the tangent at x is 1. So the graph looks like this. We're drawing the tangent here. So tangent is a line that's parallel to the curve. So you get 1 mark for drawing that line. Okay, part B says determine f dash super x. So we have f of x is x on top of x plus 1. It touches at x is 1. Because we're drawing the tangent at x is 1. So in order to differentiate, we'll do u is x, u dash is x plus 1, v, v is x plus 1, and v dash is 1. Alright, so there's our derivative function. So 2 marks there for determining f dash of x. Okay. Hence, show that the equation of the tangent to the curve when x is 1 is x take 4y equals minus 1. Now this is presented to us in general form. So we have 2 things we could do. We could find the tangent in general form in order to show it, or we could find it in y-intercept form and then convert it to general form. Okay? We have to show a link. I think it's going to just be easy to find the tangent in general form. So for a tangent, we need 2 things. We need the point of contact. We have x is 1. And the y value, well, the function is x on top of x plus 1. So if we put the number x is 1 into this equation, we have the y value is half. And then we need the slope. Well, this is our slope function. We found it in part B. So when we put x is 1 into the slope function, we'll have a slope of 1 on 4. Now also, we could get all of that information from the graph. If we graphed it and g-solve when x is 1, it's going to tell us the corresponding y value and the slope. The calculator won't write 1 on 4, it would write 0.25. Okay, so then for general form, if we have slope a on b, ax take by equals c. In this circumstance, our slope is positive. So this is the circumstance for general form we're going to follow. We have 1 lot of x, take 4 lots of y equals c. We sub in the coordinate, which is 1 times 1, take 4 times half. And so we have 1 take away 2. C is minus 1. Therefore, x take 4y is minus 1. Alright, so we get our 2 marks. QED, if you like. Yep. As required is not required. Yeah. Alright. Find the y-intercept of the line. The y-intercept, occurs when the x value is 0. So if we put x is 0 into this equation, we have minus 4y equals minus 1. And so we have y as a quarter. All right. Fill in the following table. So the equation of the tangents to the curve when x is 2 and x is 3. So the function's staying the same, but we're changing the x value where the tangent is drawn. So they're drawing the tangent at x is 2 and then at x is 3. And now we've got this table to fill in. So we have the x value, 1, 2, 3, the tangent, equation of the tangent, and then we have the y-intercept. Alright. So we saw when x is 1, the y-intercept was 1/4. And the equation of the tangent was x take 4y equals -1. Now we're given the equations of the tangent at 2 and 3 as well. Alright, so the equation of the tangents in general form, we have x take 9y equals -4, and x take 16y equals -9. Alright, so we know the y-intercept occurs when x is 0. If we put 0 into this equation, we have -9y equals -4, which means the y-intercept is 4 on 9. Here, the y-intercept is going to be 9 on 16. Is everyone okay with how we've generated those numbers for the table? Yep. Need some more space for us. Alright, so all we're doing, we've got the same function, we're just moving the tangent along the x values. Alright, and then these are the corresponding y-intercepts. Make a conjecture about the y-intercept at x is a. So they're saying if the value of x is a, what's this conjecture? What's a link between this number and the y-intercept? This is a tricky one to see.
It's the -1. It's 1 on the top, then 4, and then the 9 is on the bottom, the 16. The two ways.
Yeah, not between that number and this number, between this number, because we're interested in the tangent at x is a.
A squared, a plus 1.
Say it.
A squared divided by a plus 1.
Very good. Yep. If this number's squared, 2 squared, 3 squared. So at the top we've got a squared, and then in the bottom we have
A plus 1
a plus 1, the whole thing squared. Alright, if we go 1 plus 1 is 2, 2 squared is 4, 2 plus 1 is 3, 3 squared is 9. So that's quite a tricky conjecture to see. But our conjecture is that the y-intercept equals a squared on a plus 1 squared. Yet. Okay. Very good. Prove or disprove the conjecture you've made in part F. Alright, so what we're doing is we're going to prove that the tangent to, and the function that we have is it x on x plus 1? That's the function. The tangent to x on x plus 1 at x equals a has a y-intercept of a squared on a plus 1 squared. Alright, so all we're going to do is find the equation of the tangent at x is a to this function. That's all we're doing. Much easier than the previous conjecture we've done. So here, do you guys want to have a bit of a go yourself? Yeah?
Wait, can we use the y-intercept as a conjecture, like from our conjecture?
No, because we have to prove that that's the case. Alright, so what we'll do, to find a tangent, we need two things. We need the point of contact. So we have an x value of a and a y value of a on top of a plus 1. Then we need the slope, and we already found the slope function in part B. The slope function is 1 on x plus 1 squared. So when we put a into that function, we'll have a slope of 1 on a plus 1 squared. Okay, and here you can use general form, you can use the formula. All will work out the same way. So all will be equally, probably one process is simpler. I can't see just from looking at it. What do we want to do? We've been using general form, so should we use general form again? Or Or should we use y-intercept form?
Consistent.
Keep it consistent with general form?
Yep.
So we have slope of A on top of B, alright? Here's capital A, here's capital B. So remember, if we have slope of A on B, we write it as AX take BY equals C. So we're going to have one lot of X take A plus 1 squared times Y equals C. Alright, so we're just finding the tangent using those unknown numbers. We put in the X value of A, and we put in the Y value of A on A plus 1. So hang on, let me concentrate here. A plus 1 squared, A on A plus 1. Alright. Let's simplify this a little bit. We have A plus 1 squared at the top and A plus 1 at the bottom. So that will simplify to just this term. Which we can simplify further as well. Like if we expand this bracket, we have A, take A squared, take A, which simplifies to minus A squared. You got it? Nice. So we found the value of C. So then this is the equation of the tangent, right? 1x take A plus 1 squared y equals minus A squared. That's the equation of the tangent for any tangent at x is A. Alright? So if you put 2 in there, it's going to give you that equation. If you put 3 in there, it'll give you that equation. Alright, now we want the y-intercept. Y-intercept occurs when x is 0. So we have minus A plus 1 squared y equals minus A squared. Divide both sides by this term. And then the negative can cancel. QED. Alright, so that one is a bit easier.